Ladies and gentlemen, allow me to begin by asking you to visualize the machine you trust with your life every single day. For over 130 years, the automobile has been defined by a single, non-negotiable mechanical truth. A solid steel shaft that connects your hands directly to the front tires. We call it the steering column. To the average driver, it is just the component the steering wheel attaches to. But to a safety engineer, it has always been a nightmare. Think about it. We place a rigid, spear-like bar of hardened steel directly in front of the driver's heart. In the event of a catastrophic frontal collision, the engine pushes back, the chassis crumples, and historically, that steering column became a lethal weapon. We spent decades inventing collapsible columns, breakaway mounts, and airbags just to mitigate the danger of this one mechanical link. But what if the ultimate safety solution wasn't to cushion the blow, but to remove the spear entirely? Today, we are witnessing the extinction of the steering column. It is being replaced by copper wires, algorithms, and electricity. This is the era of steer-by-wire. And while the purists are screaming about the loss of soul, the engineers at Mercedes-Benz, Tesla, and the Chinese giants like BYD are quietly celebrating the death of a dinosaur. Today, we explain exactly why the connection had to be cut. To understand the future, we must analyze the failures of the past. The comment section will inevitably scream, "This isn't new. Infiniti did this 10 years ago." And you are right. But there is a massive difference between being in first and being ready. In 2013, the Infiniti Q50 launched with direct adaptive steering. It was the world's first production steer-by-wire system, and it was an absolute disaster for public relations. Why? Because the technology wasn't ready for the enthusiast. The processing speed, the latency between your hand moving and the wheel reacting, was technically fast enough, but the feedback was synthetic. It felt like driving a PlayStation controller with a broken rumble motor. There was no sensation of the road surface. If you hit ice, the steering wheel weight didn't change. If you hit a pothole, the wheel didn't kick back. It was numb. It was so controversial that Infiniti had to install a heavy, complex mechanical clutch and a backup steel shaft that would engage if the software crashed. It was a system that didn't commit. It was heavy, expensive, and felt terrible. It poisoned the well for steer-by-wire for over a decade. But 2013 is not 2026. The processors we have today are exponentially faster, and our understanding of force feedback haptics has evolved from simple vibration to genuine simulation. Why bring it back? If it failed before, why are Lexus, Toyota, and Tesla spending billions to revive it? The answer lies in simple physics. It is about the steering ratio. In your current car, the steering ratio is fixed. It is a mechanical compromise. To turn the wheels from fully left to fully right, you typically need 2.5 to 3 full rotations of the steering wheel. This is fine for parking, but it is terrible for high-speed stability. And at high speeds, a sensitive steering rack is dangerous, so we make it slow. We are stuck in the middle. Steer-by-wire destroys this compromise. Look at the Lexus RZ 450e. It has a variable ratio that changes by the millisecond. In a parking lot, you turn the yoke just 150 degrees, less than half a turn, and the wheels go to full lock. You never have to cross your arms. You never have to do the hand-over-hand shuffle. But as you accelerate onto the motorway, the software alters the ratio. Suddenly, that same 150-degree movement would only turn the wheels a few degrees, keeping you stable at 200 kilometers per hour. This is physically impossible with a solid steel bar. You cannot change the number of teeth on a gear while the car is moving. Only software can do this. This brings us to the Tesla Cybertruck. Say what you will about the design, but underneath the stainless steel, it solved the biggest engineering hurdle of steer-by-wire, the power problem. To turn the massive, Heavy wheels of a stationary truck without a mechanical lever requires immense torque. If you try to do this with a standard 12-volt electrical system, the same system we've used since the 1950s, you run into a wall of physics defined by Ohm's law. To get high power at low voltage, you need massive amperage. Massive amperage creates massive heat and requires thick, heavy copper cables. It is inefficient and dangerous. Tesla's move to a 48-volt architecture was the key that unlocked the cage. By quadrupling the voltage, they could reduce the current by a factor of 4. This means thinner wires, lighter motors, and faster reaction times. The actuators on the Cybertruck's steering rack can apply force faster than a human can perceive. This allowed Tesla to do what Infiniti could not. They deleted the mechanical backup entirely. There is no column, there is no clutch. If the power dies, the steering dies. This level of commitment is what scares people, but it is also what drives the industry forward. Let's step away from the driving experience for a moment and look at the money. Because ultimately, the car industry is a business. Why are Chinese giants like BYD, Geely, and Xiaomi pushing this so hard? It is not just for technology's sake. It is about manufacturing logistics. Think about the nightmare of building a world car. In the UK, Australia, and Japan, we drive on the left, so the steering wheel is on the right. In Europe, America, and China, it is the opposite. For 100 years, this meant engineers had to design two different chassis. The steering column, the brake booster, the pedal box, the HVAC plumbing, everything had to be mirrored. It costs billions in tooling. With steer-by-wire, that problem vanishes. You want the steering wheel on the right? Fine. Just bolt the screen and the wheel to the right side and plug in the wire. Want it on the left? Move the plug. The chassis remains identical. The mechanical rack doesn't need to be rerouted around the engine block. The savings in tooling, complexity, and assembly time are astronomical. This is why the accountants are killing the steering column just as fast as the engineers are. While Tesla is breaking things and moving fast, Mercedes-Benz is playing the long game of validation. You might think the Germans are late to the party, but they have been implementing this technology from the back to the front. Look at the Mercedes S-Class and the EQS. They feature rear-wheel steering with up to 10 degrees of angle. That rear axle has no mechanical connection to the steering wheel. It is purely steer-by-wire. Mercedes has been collecting data on millions of kilometers of wired steering on the rear axle to prove reliability before they sever the connection on the front axle. Furthermore, Mercedes needs this for Level 3 and Level 4 autonomy. In the Drive Pilot system, when the car takes control, the steering wheel becomes a useless obstruction. In the future concepts from Stuttgart, the wheel will retract into the dashboard, giving the driver more space to work or relax. You simply cannot retract a steering wheel that is bolted to a fixed metal shaft. The death of the column is a requirement for the luxury of the future. Now we look to the east, where the implementation is happening at lightning speed. China does not have the legacy burden of 100 years of internal combustion history. Brands like Xiaomi and BYD view the car not as a mechanical product, but as consumer electronics. The Xiaomi SU7 and the Yangwang U8 are prime examples. By removing the steering column, they free up the Monfrunk space. They simplify the assembly line, and they enable features that sound like science fiction. The e-tank turn on the Yangwang U8 or the crab walk modes are only possible when the computer has total authority over wheel positioning. If your hand was mechanically linked to the wheels during a tank turn, the steering wheel would be spinning at 1,000 RPM. Breaking your thumbs. Steer-by-wire disconnects the violence of the wheel movement from the calm of the cabin. It is the ultimate filter. This is the part of the script where we address the fear, the sheer, primal terror of driving at 70 miles per hour and losing electrical power. What if the fuse blows? What if the battery dies? These are valid questions, but the engineering answer is robust. Redundancy. In a steer-by-wire system, nothing is singular. The system in the Lexus and the Tesla uses a fail-operational architecture. There are two independent battery feeds. There are dual-wound motors, essentially two motors inside one housing. If one winding fails, the other takes over instantly. There are dual processors running in parallel, checking each other's calculations constantly. It is the exact same philosophy used in the Airbus A350 or the F-35 fighter jet. There are no cables connecting the pilot's stick to the ailerons. It is all data. We have trusted this technology in the skies for 40 years. The car industry is simply finally catching up to aerospace standards. The likelihood of a total, catastrophic failure of all redundant systems simultaneously is statistically lower than the likelihood of a mechanical steering shaft snapping due to metal fatigue. We are witnessing the digitization of feel. Purists will mourn the loss of the mechanical connection, arguing that you can no longer tell what the front tires are doing. But the truth is, most modern cars with electric power assist, EPAS, have been numb for years. Steer-by-wire actually offers a solution. Because the feedback is generated by a motor in the steering wheel, engineers can program exactly what you feel. They can program the resistance to increase as the tires lose grip, warning you of a skid even clearer than a mechanical system could. They can filter out the annoying vibration of a rough road while amplifying the sensation of a corner. It is like moving from an analog vinyl record to a high-resolution, lossless digital file. Is it the same? No? Is it technically superior in clarity and customization? Absolutely. The steering column had a good run. It served us from the Ford Model T to the Porsche 911. But its time is up. The convergence of autonomous driving goals, the need for variable steering ratios, the switch to 48-volt architectures, and the relentless efficiency of Chinese manufacturing has signed its death warrant. The car is evolving from a machine of gears and oil into a node of data and electricity. The disconnect is real, but it is also liberating. It allows for safer crash structures, better packaging, and impossible maneuvers. So, the next time you get in your car and grip that wheel, remember, you are holding on to history. Because in the showroom of tomorrow, that connection will be gone. The steering column is dead. Long live the wire.